be showcasing the amount of energy it takes to do certain lifts, and then I'm going to use that information to compare it to how much energy it takes to light a light bulb, and I'm going to compare different movements and see how they affect the amount of energy or how many watts you can produce. I'm going to start off with a simple bench press just to get a base value to see how much energy that takes, and then I'm going to compare an overhead press to a barbell curl, and then I'm going to see the difference in energy there. They're going to move the same height, the weight's going to be the same, and I'm going to try to lift them as fast as possible to see the greatest energy output I can have per second, so the largest amount of watts, and then I'm going to see how the two values compare. So here I have the amount of weight in pounds I'm going to be lifting for bench press. These are the plates that will be on each end of the barbell. 4.55 kilograms, 3.63 kilograms, and the bottom one is 4 kilograms. And then here's the weight of the bar itself. So after converting all the values to kilograms, meters, and applying gravity to the work equation, the bench would end up doing 112.85 joules. And I actually thought it would be a lot more. I did not think it would be that low of a number, and then the watts would turn out to be 132.76 joules per second. So I could light a 100-watt light bulb for about 1.3 seconds, which is not a lot of time. Showing and it wasn't a little bit of weight. It was 52 or whatever pounds, and it only lights a light bulb for 1.3 seconds. Some people might have a hard time doing that. So each arm was only able to light a light bulb for 1.3 seconds. That's crazy to me. The overhead press would end up being 265 watts or 220 joules. That makes sense that it was able to do it as fast as it did compared to the curl, even though they were the same weight and the same distance, because it's just larger muscle groups I can utilize to do so. And I'll try to keep this in mind. I try to do each exercise as linear as possible to reduce angled movements, because that would then affect the height. I try to do them as straight up as possible. And then we go to the curl, and obviously that is it did less, well, it would do the same amount of joules, but because it took more time, it would produce less watts, which again, that makes sense because it's a smaller muscle group than the entirety of the back and the shoulders as they produce with overhead press. But I mean, this just puts into perspective the amount of energy compared to humans that a light bulb would take, because if you wanted to light your light bulb for a couple of hours, the amount of overhead presses you would have to do to generate that amount of energy, it just puts a whole new perspective into my head that wasn't there before. And yeah, that's just crazy to me. How many overhead presses you have to do to generate the same amount of energy to keep your light on? It's crazy. I know I only did one repetition of each there, and I didn't really include the negative movement, the way down for each one, but the way up, the first one, it's usually the easiest, but then as time goes on, it usually takes more time, and usually you burn yourself out, and that's a lot of energy to utilize. If, say, I wanted to overhead press to try and generate enough, or to try and utilize the same amount of energy as a light bulb that has been on for a few hours, it's that would physically challenge you, and then we just have this light on it's nothing utilizing that same amount of energy. So the comparison of exerting that much energy as a human, and then that energy to light a light bulb with that one over here, I just find that comparison to blow my mind, really. So I hope I was able to put into perspective in a way we can relate to lifting heavy objects, the amount of energy compared to lighting a light bulb that our house uses. And, I hope I put it into a new perspective for you.